Hi guys, in this video we are going to see a guide to the different types of APIs. So first, before continuing to the video, first let's see what is an API. So API are one of the most important components of modern day development, forming the bridge between the applications to transfer information and deliver services. However, even as a developers and C-suite, executives increasingly consider APIs early in the development lifecycle. There remains some confusion about which types of APIs are best suited to particular application. So each API has its own architecture, which evolved to meet the demands of the time. As the technology has developed over the years and our relationship to technology has shifted, we have seen APIs to fill new gaps and serve different users. So in this video, we will run through the different types of API protocols to give you a sense of their pros and cons, common uses, cases, and other consideration while you are choosing the best one for your needs. So let's get started. So first, let's start with the REST APIs. REST APIs are designed to make server-side data readily available by representing it in simple formats such as JSON and XML. The acronym stands for the Representational State Transfer, and it was released in 2000 after being introduced in academic thesis by Roy Fielding. The particular type of API adheres to six specific architectural constraints, which are the uniform interface, completely stateless, native caching, client-server architecture, a layered system, and the ability to provide executable code to the client. What are the pros and cons for that? So let's talk about the pros. Operations are executed with different HTTP methods, including GET, POST, PUT, delete options, and patch. By leveraging these functions, REST APIs become extremely capable across the internet. The key benefit of these API types are that the clients and server are completely decoupled from one another. This allows for abstraction layers that helps to maintain flexibility even as a system grows and evolves. In addition, REST is cache friendly and supports multiple formats, which is important when you are building public facing APIs. The flexible data formatting that you get as a result makes them extremely useful for varied application. RESTful APIs are most commonly used as management APIs to interact with objects in a system. They are also useful when you are building a simple resource driven application that does not need much in terms of query flexibility. About cons, the RESTful APIs fall short in that they rich metadata because it creates a big payload that can sometimes cause more trouble than they're worth. You can get over and underfetching problems that require further API requests, bogging down the process. And from an industry perspective, another key externality resulting the flexibility is that there is no binding contract on which structure is used for messages. As a result, there is a lot of back and forth when it comes to implementation, which can cause unnecessary frustration and bottlenecks. This was all about REST. Now let's talk about another API type, which is the SOAP. SOAP are formatted as XML files and they are extremely common web communication protocols. The acronym stands for the Simple Object Access Protocol and it was developed in the late 1990s. Despite its age, SOAP still remains one of the most popular API types used by developers. So let's get with its pros and cons. Talking about pros, the major advantage of SOAP is the fact that it is completely agnostic when it comes to the programming language and processing platform. The standardized format ensures that no matter what is receiving the message on the other end, the request can be executed. In addition, this type of API comes with native error handling already built in, and it helps developers to be proactive and solve issue before they snowball. And perhaps the strongest SOAP use case is with high security data transmission in situation where two parties have agreed to a specific legal contract. Here, SOAP standardization works wonder because it always for the contract terms to be formally codified and enforced throughout all of the API's processing. You will see plenty of high stakes industries like financial service where data being passed back and forth is highly sensitive, uses SOAP as their API protocol. About cons, SOAP standardization makes requests incredibly accessible to applications, but as a side effect, the format can be very formal and verbose. So every message must include an envelope tag at the start and at the end, a body that includes the actual request, a header for specific information and additional requirements, as well as any faults that occur during processing. SOAP has become less popular in recent years because of the sheer volume of information it requires. The XML files are large and often unnecessarily clunky, especially for simple systems. The number of people who specialize in SOAP servers is rapidly declining, and that makes it difficult things to maintain if you don't already have the right talent on abroad. It feels like the format is lagging behind newer, more flexible communication methods that offer more robust, sustainable results. Next one is the GraphQL. It was developed in response to the REST APIs with the idea that you could execute precise syntax that retrieves only what is needed, lightening the payload and simplifying the process significantly. It is an internal Facebook protocol that was first released in 2015, quickly become the go-to API type for the JSON. You can start by creating a schema that describes all the possible queries and specific types that they return. This can be challenging, but once completed, the API can accept specific request and return result that matches exactly what user is looking for. And there remains a heated debate in the technology industries as to whether companies should build a GraphQL API alongside an existing REST API or whether it should be a complete replacement. If you are ever looking to stir up some controversy among developers, this is a good way to do it. So let's get about the pros and cons. The advantage of immersing yourself in GraphQL APIs are the APIs queries that are transparent and well documented, gives users all the information that they need to use it effectively. In addition, the precise results, detailed error message, and the flexible permissions help around out a well-balanced, high-functioning APIs. This is especially true when it comes to data structuring, where GraphQL gives user significant flexibility. But about cons, performance can suffer with GraphQL if you have too many nested fields in one request. It doesn't reuse the standard HTTP caching semantics, so it actually requires custom efforts to achieve proper caching. So all this makes GraphQL difficult to pick without lots of training and experience. It certainly is an acquired skill, breaking away from the long track record and industry knowledge around the REST APIs. Next one is gRPC. So gRPC, in that RPC stands for remote procedure call and refers to something that can execute a function housed elsewhere but in a different context. The G appends at the beginning narrows things down to the most advanced version developed by the Google in 2015. A user on one side will select a remote procedure to execute, serialize the necessary parameters, and then append any additional information into the message. This will be sent to the server, which interacts with the other application, decoding the message and executing the operation. A result then comes back to the initial user. About pros, this is a powerful form of API because of its simplicity. It is straightforward, using get to fetch the information and post for everything else. This means that functions are easy to add, and for lightweight payloads, you get great performance overall. The ability to define any type of function makes it indefinitely configurable. Essentially, you are limited only by your imagination. Typical use cases include commands APIs that send simple requests to remote system and customer specific APIs which helps manage internal microservices at a scale with great speed. By simplifying otherwise complex remote calls, gRPC has also become a staple of Docker-based application world, providing its value when you have a massive number of remote calls to execute. Talking about cons, where gRPC falls short in the fact that it is tightly coupled to the underlying system, which restricts its reusability in many cases. In addition, there is no abstraction layer sitting between the APIs and the actual system function, which can raise security concerns. So in this video, we had seen the REST APIs, the SOAP, then the GraphQL and gRPC. So in next video, we will get into some another computer science lecture. So till then, bye bye.